Hi guys, welcome back to snt-networks. In today's video, we'll be discussing about hashing and load balancing. So, you know, it's not really, to be honest, not really about load balancing, right? If you think about load balancing, do not think about just a load balancer, right? Because, like we discussed in a previous video about packet flow, right? I hope all of you remember it. If you don't, please go ahead and have a quick recap on the video. You can click on the I button to do so. Now about load balancing. So to give you a quick overview on load balancing again, let me just talk about it. Considering you are on a network, right? Your newly connected machine, like we discussed, this is your router, your internet gateway, this is your ISP, and this is your server. If you're trying to reach a server, what do we say? That a series of events happen for to make sure that your packet goes out, correct? So the packet will be built basically from 7 to 1 in the OSI layer, right? Nowadays we use this TCP IP, so it is just 4 layer. That's different. But then in this case, what would happen is if you're using 7 to 1, you know, so the first thing will be you basically go ahead with the DHCP DORA process to get your IP address, your default gateway, your subnet mask, and your DNS address. Then you use a DNS to change that Google, for example, if photos.google.com to convert it into an IP address. From here, you do a AND function to check if that particular IP belongs to the same subnet or not. Accordingly, you'll send out your traffic. Then you send all the packet basically to the IS through your default gateway. I mean, sorry, you send the packet to your default gateway, right? Just to make sure that you know uh, your packet is basically flowing in the right direction, right? So now once I've sent the packet here, per hop, the MAC address will change, right? But the IP of source and destination will be static. Okay, because even these, the server will maintain a session, a list, or a table. Now, again, one more thing will happen is you use the IP address. Once you do what's my IP, you will get the IP address here. What's your, internet IP or your public IP. Okay, use that. Then, from your default gateway, the net using NAT, your traffic will go outward in the internet, and through that, it will reach the through routing it between underlay whatever routing mechanisms we have. We can either have OSPF, BGP, ISIS, whatever we have. It could be a lot of devices in between, right? But every packet has a shelf life. By shelf life, I mean it can be only circulated a number of times, right? So even we for that we have TTL values. Okay. Now what I am saying is, so once it reaches the Google server, you have a TCP three-way handshake to basically establish a connection. Then you do SSL to make it secure, and then you have HTTP to fetch the data. Now here what happens in between? This is the main part. This will tell you how the internet works. This is again very important. Now, why are we discussing about this? Because, for example, let me take you to a new section. Now probably you will understand a bit better. Considering you're here again, now this part is your ISP. Okay. Now here it could have n number of devices, right? N number of routers. You can have n number of routes, okay, from where your packet can flow, right? And from here you have a router, and this is your Google server. So how do we know which route to take? Plus, even in networking, we say it very clearly that we want to maintain a flow. If you have gone through the IP header, you would know that for IP header we use fragmentation, right? I mean, if we do fragmentation, we particularly use the IP address, and even with TCP or the IP, if you have an IP from the IP address, we use fragment offset, right? And identification to basically if packets are fragmented to order the packets. Okay. Similarly, we use TCP for that. We use TCP and make sure that the flow control is in order. By flow control, I just don't mean to control the flow, but to also assemble the packets in the buffer. That also helps you, right? Because once you look at the packet capture, you can see that how the packets are generally assembled, right? So that is another thing. Now, if you use different flows, for the first time, considering I'm using this flow, it's going here, 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 and it reaches here. Second time when the packet comes, I'm using this flow because it also depends on the cost. For example, right? If the cost is different, it will take different paths. So this is where the hashing part comes in. This is why we use hashing so much that it helps you order the packets. So let's just go in a bit of theory and then we'll basically learn in depth how does this work. So in networks there are often multiple paths available between source and destination to make the network more efficient, faster and reliable. Routers can distribute traffic across the different paths. This is called load balancing. Correct? So why not just send packets randomly? Because sending packets randomly across multiple paths can lead to problems, right? Packet belonging to the same flow, basically a sequence of related packets like a single website download or a video stream, might arrive at a destination out of order. For example, like I told you, first, third, sixth, the rest two packets where I needed two, right, four and five, they're lost. They might come after it. So the ordering is lost. So because of that, if the ordering is lost, they might arrive at the destination out of order. This can cause the applications to rely on order delivery like TCP. Correct? And hashing to the rescue. It basically creates a thing called sticky flows. This you should remember. If anybody asks you about hashing, what exactly is hashing in routing, where the packet flows, towards the internet, how does it work? You can talk about sticky flows. So this is where hashing comes in. Routers use a hash function, a mathematical algorithm, right, to look at certain parts of a network packet and generate a fixed size output called a hash value. This hash value might use the same algorithm that you use in security, IPsec, SSL, all of that, where there you basically use for identity purposes or identity or integrity, right, for security. But for this one, you use basically for routing purposes to make sure the packets arrive in order. Okay. Now, if this is clear, let me just rub this off and then we'll talk about the next part. So for the next part, now we'll basically talk about sticky flows. How does it work? Why does it work? Why we talked about why do we need it? We need it for ordering packets, making sure uh, not every time we can use TCP. Correct. Sometimes we are just sending packets across without TCP. I'm using a simple OSPF protocol to send data, right? Uh, but then why do we need it? We understood to make sure that network packets are basically arriving at an ordered rate and basically in an ordered function. Now, how does it work? Basically, let me just draw a bit of diagram so that it will be easy for you to understand. So this part was the internal, forget it. Now this is the Google server. Here in between, let's talk about it. So we have a router. Okay. Now I have two specific paths here. For example, okay, let's create a simple diagram. I have two routes. So either it can go through this route, okay, or it can go through this route. Okay, two ways. Now, how does it decide? For the first time, for example, for the first time, if my packet, this is the Google server. For the first time, if my packet went through this route, for example, now what will happen is, so the a router receives packet that needs to be forwarded and has multiple this thing, what do you call, equal cost. So now, for example, if both from the so the decision making will be done at particularly this router. So arriving at this router, now you know that it has equal cost from here and from here. Okay, this is what you want to make sure. Even though we have two hops here, correct, it is the same, right? From here we have two hops, another we have two hops. So for example, it has equal cost. Okay. Now it has to make sure basically from which router will it, which link or which router will it use to forward packets. Now what happens is it uses a thing called, you can say 5 tuples, 6 tuples like we use in security. You can say source IP address, destination IP address, source port, destination port, and protocol. So these are 5 tuples that it uses to ensure. So with these things, what it will do is, you know, it will create a hash function. Now it has a hash value. Like I told you, it is not like security. It does not create a hash function to generate a digital signature or a fingerprint or something. It just stores the hash value to make sure that it has the right path. Right. Now the router creates a hash function. It creates a hash value. Now so the next time when a packet is arriving, okay, for example, when the next time a packet is basically arriving here, a packet arrived here. Let me use a different color. I think it will not be feasible for you guys to see. So if we use this, so next time a packet came here, okay. Now what happens is now the decision making is with this particular router. Okay. Now it checked. What it will do is the router uses the hash value to decide which of the available outgoing link it has to use. So a common way that it uses is to do a modulo operation, right? Basically dividing the hash value by number of available links and taking the reminder. Okay. So, and again, another thing you can do is what it does is it will just take the hash. It will for the fresh packets, right? Again, it will create a hash value. It will see if it matches or not. If it matches that value, it will use the same path. It will not use this path again. Okay, it will use the same path for consistency. Now, why do we do it? So we understood how it does it. It uses a hash value to make sure, just like a session marking. Why do we do it? Okay, so we do it basically because of consistency. Because the hash function is deterministic, right? The same input, the same 5 tuples will always generate the same hash value, correct? So now all packets belonging to the same flow will go only through that same route. So we have a consistency, right? This means router will consistently choose the same outgoing link, right? Preventing out of order. So now first thing is we have ordered packets. Okay. The second thing. The second thing is now you maintain a flow order, like I told you, ordered packets. Now you can use distributed traffic. By what do I mean by distributed traffic? By using a good hash function, right? Distributed flows are likely to generate different hash values, leading to relatively even distributing loads. So you can use again hash value for distributing loads. Okay. This is again same used in basically load balancers to distribute the traffic. Okay. The third thing is that is very important is statelessness. Now you don't need TCP, right? So routers don't need to keep track of individual flows. They just use simple, hashing to make sure about the flow, and forward decision is basically, made on the information present in each packet. So if each packet will have the same tuples, it belongs to the same flow. Correct. Different flow, different tuples, different flow. So if I have to basically, summarize all this, I can say that hashing is for load balancing, right? Is used basically being a stateless flow of traffic just to make sure that you use same path always, right? How does it help us? It helps us with out of order packets, distributing, help us to reduce out of order packets and make sure you have ordered packets, distributing loads, and then using, even while using statelessness, you can basically routers, because routers are stateless. So even when a router is stateless, you don't need to track individual packets or make tables. You can use just a hash value to make sure that packets reach, in a ordered fashion rather than, basically unordered. So that is why we use hashing in load balancing. The difference it would have against security would be like a simple this thing, because hashing for load balancing is different from cryptographic hashing that we use in security, IPsec and SSL, right? Here the goal is just efficient traffic distribution, not data security. There we use for integrity, making sure the packet is coming from the right host. Here we're just making sure if it is coming from the same 5 tuples with the same hash value, it has to be assigned a particular flow. That's it. That is, the basic, flow in which hashing and load balancing works. This is very different from, different hashing that we have heard. A lot of you might not be able to relate, but this again will help you understand how does internet work. Okay, because the internet can have a number of protocols in between. It can have OSPF, BGP, right? RIP, I don't think it will have. Let's just we are considering, and then we have ISIS. ISIS is widely used. We have MPLS as well, right? Again, it's static, one-on-one, but still, I'm just telling you, it can have a number of things. But just to distribute loads, the decision maker, right, will use hashing to make sure that the flow is remains uninterrupted and is always ordered. So this was all about hashing. Please do let me know. It was just an overview. We will present you with a detailed video with probably a bit of animation though, so that you can understand better. I hope this was helpful for an overview. Please let me know if you have any questions. Thank you.